Storing keys with associated values in hash maps. Uh, the last of our common collections in the hash map, the type hash map stores a mapping of keys of type K to values of type V using a hashing function, which determines how it places these. The last of our common collections is the hash function. The type stores a mapping of keys of type K to values of type V. Stores a mapping of keys of type K to values of type V. Okay. Which determines how it places these keys and values into memory. Many programming languages support this kind of data structure, but they often use a different name, such as hash, map, object, hash table, dictionary, or associative array, just to name a few. Hash maps are useful when you want to look up data, not by using an index, as you can with vectors, but by using a key that can be of any type. For example, in a game, you could keep track of each team's score in a hash map in which each key is a team's name and the values are each team's score. Given a team name, you can retrieve its score. Hash maps are useful when you want to look up data, not by using an index. Hash maps are useful when you want to look up data, not by using an index. Okay. As you can with vectors. But by using a key that can be of any type. For example, in a game, you could keep track of each team's score in a hash map in which each key is a team's name and the values are each team's score. Values are each team's score. Given a team name, you can retrieve its score. Okay, we will go over the basic API of hash maps in this section, but many more goodies are hiding in the functions defined on hash map by the standard library. As always, check the standard library documentation for more information. We will go over the basic API of hash maps in this section, but many more goodies are hiding in the functions defined in the hash map by the standard library. As always, check the standard library documentation for more information. Creating a new hash map. One way to create an empty hash map is using new and adding elements with the insert. Creating a new hash map. One way to create an empty hash map is using new and adding elements with insert. In listing 8-20, we are keeping track of the scores of two teams. Listing 8-20, creating a new hash map and inserting some keys and values. New insert key and value. Okay. Note that we need to first use the hash map. Note that we need to first use the hash map. We need to first use the hash map. Okay, from the collections portion of the standard library. Okay, and of our three common collections, this one is the least often used, so it's not included in the features brought into scope automatically in the prelude. Makes sense. Hash maps also have lesser support from the standard library. Hash maps also less support Similar library. There's no built-in macro to construct them, for example. Uh, just like vectors, hash maps store their data on the heap. Okay, heap. This hash map has keys of type string and values of type i32. Like vectors, hash maps are homogeneous. All of the keys must have the same types as each other, and all of the values must have the same type. Just like vectors, hash maps store their data on the heap. This hash map has keys of type string. This hash map has keys of type string and values of type i32. Like vectors, hash maps are homogeneous. All of the keys must have the same type as each other, and all of the values must have the same type. Accessing values in a hash map, we can get a value out of the hash map by providing its key to the get method as shown in listing 8-21. Just like vectors, hash maps store their data on the keys. This hash map has keys of type string and values of type i32. Like vectors, hash maps are homogeneous. All of the keys must have the same types as each other, and all of the values must have the same type. Accessing values in a hash map, we can get a value out of the hash map by providing its key to the get method, as shown in listing 8-21. Oh, here, scores, get, team name, blue, copied, unwrap. Accessing this score for the blue team stored in the hash map. Here, score will have the value that associated with the blue team, and the result will be 10. This get method returns option. Okay. If there's no value for that key in the hash map, get will return none. This program handles the option by calling copied. This program handles the option. By calling copied to get an option i32 rather than an option i32. Okay. Then unwrap or to set score to 0. If a scores doesn't have an entry for the key. We can iterate over each key value pair in a hash map in a similar manner as we do with vectors, using a for loop. So if I use a copy, then to get an option i32, literally copy the value. To get an option i32, not option. Okay. We can iterate over each key value pair in a hash map in a similar manner as we do with vectors, using a for loop. Hash map and effect. Okay, so here key value in ampersand score and then key value. Key value. Okay. This code will print each pair in arbitrary order. Hash maps and ownership. For types that implement the copy trait like i32, the values are copied into the hash map. For owned values like a string, the values will be moved and the hash map will be the owner of those values, as demonstrated in listing 8-22. Insert field name, field value, field name, in at this point, try using them. Okay. So we are unable to use the variables field name and field value after they've been moved into the hash map with the call to insert. We aren't able to use the variables field name and field value after they've been moved into the hash map with the goal to insert. We are unable to use the inner variables field name and field value after they've been moved into the hash map with the goal to insert. We aren't able to use the variables. We aren't able to use the variables field name. We aren't able to use the variables. Okay, after they are moved into the okay. If we insert references, to values into the hash map, the values won't be moved into the hash map. The values that the reference point to must be valid for at least as long as the hash map is valid. The values that the references point to must be valid for at least as long as the hash map is valid. Oh, okay. Must be valid. We will talk more about these issues in the validating references with lifetime section in chapter 10. Updating a hash map. Although the number of key and value pairs is growable, each unique key can only have one value associated with it at a time. Although the number of key and value pairs is growable. Updating a hash map. Although the number of key and value pairs is growable, each unique key can only have one value associated with it at a time, but not vice versa. For example, both the blue team and the yellow team could have value 10 stored in the score hash map. When you want to change the data in a hash map, you have to decide how to handle the case when a key already has a value assigned. You could replace the old value with a new value, completely disregarding the old value. You could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value. Or you could combine the old value, the new value. Let's look at how to do each of these. Overriding a value. If we insert a key and a value into a hash map and then insert that same key with a different value. Okay, wait a second. If we insert a key and a value into a hash map, and then insert that same key with a different value. If we insert a key and a value into a hash map, if we insert a key and a value into a hash map, and then insert the same key with a different value, the value associated with that key will be replaced. Even though the code in listing 8-23 holds insert twice, the hash map will only contain one key value pair because we are inserting the value for the blue team's key both times. Listing 8-23 replacing a value stored with a particular key. This code will print blue 25. The original value of 10 has been overwritten. Adding a key and value only if a key isn't present. It's common to check whether a particular key already exists in the hash map with a value, then take the following actions. If the key doesn't exist in the hash map, the existing value should remain the way it is. If the key doesn't exist, insert it and a value for it. Hash maps have a special API for this called entry that takes the key you wanna check as a parameter. The return value of the entry method is an enum called entry that represents a value that might not exist. Okay, wait a second. Hash maps have a special API. Hash maps have a special API for this called entry that takes the key you wanna check as a parameter. The return value of the entry method is an enum called entry that represents a value that might or might not exist. Let's say we want to check whether the key for the yellow team has a value associated with it. If it doesn't, we want to insert the value 50, and the same for the blue team. Using the entry API, the code looks like listing 8-24. Hash map scores insert blue 10 entry yellow string insert listing 8-24 using the entry method to only insert if the key does not already have a value. Listing 8-24 using the entry method. Listing 8-24 using the entry method. Using the entry method to only insert if the key does not already have a value. The listing to 8-24 using the entry method to only insert if the key does not already have a value. Listing 8-24 using the entry method to only insert if the key does not already have a value. Listing 8-24 using the entry method to only insert if the key, okay. So does not, if the key does not have already, does not already have a value. Entry or insert 50. The OR insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists. And if not, inserts the parameter as the new value for this key. And returns a mutable reference to the new value. This technique is much cleaner than writing the logic. This technique is much cleaner than writing the logic ourselves, and in addition, plays more nicely with the borrow checker. Running the code in listing 8-24 will print yellow 50, blue 10. The first call to entry will insert the key for the yellow team with the value 50 because the yellow team doesn't have a value already. The second call to entry will not change the hash map because the blue team already has the value 10, updating a value based on the old value. Updating a value based on the old value. Another common use case for hash maps is to look up keys value and then update it based on the old value. For instance, listing 8-25 shows code that counts how many times each word appears in some text. We use a hash map with the words as keys and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, we will first insert the value 0. Another common use case for hash maps is to look up a key's value and then update it based on the old value. For instance, listing 8-25 shows code that counts how many times each word appears. Another common use case for hash maps is to look up a key's value. Another common use case for hash maps. Another common use case for hash maps. Another common use case for hash maps. To look up a key's value and then update it based on the old value. For instance, listing 8-25 shows the code that counts how many times each word appears in some text. We use a hash map with the words as keys and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, we will first insert value 0. Listing 8-25, counting occurrences of words using a hash map that stores words and counts. This code will print world2, world2, hello one, wonderful one. Hello world, wonderful world. Text split in I space. Okay, and then entry word or insert. Map entry world map entry world or insert world or insert 0. Okay, so very small. Okay. If there's a word in word, yeah, makes sense. Okay. So this code, okay, makes sense. You might see the same key value pairs printed in the different order. Recall from accessing values in hash map section, the iterating over a hash map happens in an arbitrary order. The split whitespace method returns an iterator over subslices. The split whitespace method returns an iterator over subslices separated by whitespace of the value in text. The or insert method returns a mutable reference mut v to the value for the specified key. Here we store the mutable reference in the count variable. So in order to assign to that value, we must firstly reference count using the asterisk. The mutable reference goes out of scope at the end of the for loop. So all of these changes are safe and allowed by the borrowing rule. Okay, wait a second. The or insert method returns a mutable reference. The or insert mutable reference to the value. Okay, to the value. Reference mutable. Okay, mutable reference. Okay. To the value for the specified key. To the value for the specified key. Here we store that mutable reference in the count variable. So in order to assign to the value, we must first dereference the count using the asterisk. Here we store the mutable reference in the count variable. So in order to assign to the value, we must first dereference the count using the asterisk. The mutable reference goes out of scope at the end of the for loop. So all of these changes are safe and allowed by the borrowing rules. Hashing functions. By default, the hash map uses a hashing function called a zip hash that can provide a resistance to denier of service. By default, hash map uses a hashing function called zip hash. Use a hashing function that can provide resistance to denier of service (DOS) attacks. Denier of service involving hash tables. This is not the fastest hashing algorithm available, but the trade-off for better security that comes with the drop in performance is worth it. If you profile your code and find that the default hashing function is too slow for your purpose, you can switch to another function by specifying a different hasher. A hasher is a type that implements the build hasher trait. We will talk about traits and how to implement them in chapter 10. You don't necessarily have to implement your own hasher from scratch. Traits.io has a library shared by other procedures that provide hashers implementing many common hashing algorithms. Okay. Determine whether the program will pass compile. Okay, so std collection hash map, mute hash, okay, normal h insert, okay, k10, okay, and we want 9%. No, I don't think it is one. So we'll fine. Okay, this is the collection hash map, then with h hash map. I see in hash characters enumerate so H E and blah blah blah. Okay, and then okay. What? What is this? For insert H entry or insert. Oh, this is so weird. Not compile because of the line 5. This is so weird. Oh shit. Six? Oh, Jesus Christ. H cannot be mutated. Oh, this works. That's so bizarre. Okay, anyway. H cannot be mutated. H insert to key to 1. While an immutable reference V1 to it is alive. Okay, so this is possible. But anyway, V1 and V1 is alive because it's immutable reference. Thus, we cannot use this. Makes sense. This program stores a vector. This program stores a vector of indexes. This program stores a vector of indexes for each occurrence. The program stores a vector of indexes. The second one, for instance, like this. This is so confusing. H entry or insert. I saw only this one, but then you are doing like this. Just very weird. Summary: vectors, strings, and hashmaps will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Vectors, strings, and hashmaps will provide a large amount of functionality. Vectors, strings, and hashmaps provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Given a list of integers, use a vector. Given a list of integers, use a vector and return the median. When stored the value in the middle position, and mode, the value that occurs most often. A hash map will be helpful here of the list. Here, order of the list. Convert the strings to Pig Latin. The first consonant of each word is moved to the end of the word and AY is added to it. So first it becomes a SFA. Words that start with a vowel have an A added to a new. You should know here or something. Okay, this is exercise. Okay. The Sender Library API documentation describes the method that vectors, strings, and hashmaps have that will be helpful for these exercises. We are getting into more complex programs in which operations can fall, so it's perfect time to discuss error handling. We will do next.